Good morning, students. Today is the lecture about vector field. Okay, in previous lectures, we discussed scalar field. Then, what is scalar field? Limit and continuity of the scalar field. Some examples of limit and continuity. How to calculate limit of the function. How to check whether the function is continuous or not. Okay, these all the concepts are discussing on vector or discussing on scalar field. This scalar field means the field which is defined from R into R. Okay, the field is defined from R into R. And today we discuss about vector field. Okay, now what is difference between scalar field and vector field? Okay, first we see the definition of vector field, then we know the difference between scalar field and vector field. Okay, so first definition of vector field is a function f is defined from Rn to Rn is called as vector valued function. In scalar field, we consider the function f defined from Rn to R, and here the difference is the function f is defined from Rn to Rn. Then the function is called as that field is called as vector valued function. This is only difference between scalar field and vector field. Okay, so in this vector field also we discuss limit and continuity of that field, how to calculate limit of that function, how to check the continuity of the function. Okay, some theorems of continuity on and some theorems on limit, algebra of limits and continuity. All the concepts are same, but only here the difference is we discussing or solving examples from Rn to Rn. Okay, so for Rn to Rn, we use norm here, norm, and Rn to R, the function is in the modulus form, but here function is defined from Rn to Rn. So in both the cases, we use here norm. This is only difference between scalar field and vector field. Okay, by solving some examples, you can understand about this concept. So, what is example of scale of vector field? Okay, so we consider one example. Look at this. F is equal to R2 to R3. F is a function defined from R2 to R3. Okay, the function is f of xy is equal to x plus y, x minus y, x square plus y square. Okay, so f of xy is equal to here x plus y. It is also function of x and y. X minus y. It is also function of x and y. X square plus y square. It is also function of x and y. That means what? The function f of xy operated on that coordinate function. These are functions of x and y. These also the coordinates are also the coordinate itself are functions of x and y. So this f1, f2, f3 function defined from R2 to R. Since only two coordinates x and y, therefore the function f1, f2 and f3 are defined from R2 to R, and it can be defined as f1 of xy is equal to this x plus y, f2 of xy defined as x minus y, and f3 of xy is x square plus y square. These f1, f2 and f3, these functions are called as component function of that function f of xy. So, now that we clear the idea about vector valued function, it is defined from Rn to Rn. So, remember that it is defined from Rn to Rn. Okay. नेक्स्ट कंपोनेंट्स ऑफ वेक्टर व्हॅल्यूड फंक्शन आत्ताच बघितलं आपण कंपोनेंट्स म्हणजे काय ते ओके एक वेक्टर व्हॅल्यूड फंक्शन विच इज डिफाइंड फ्रॉम Rn to Rn. It is given by f of x is equal to f1x, f2x and so on fmx. These f1, f2, fm are called as component function, and these functions are defined from Rn to R. These functions are scalar valued function. Okay, and these functions are called as component function. So if the valued function is defined from Rn to Rn. ओके म्हणजे एफ वर एफ फंक्शन हे Rn मधल्या फील्डवरती ऑपरेट केल्यावर मिळणारं तुम्हाला जे काही त्याची इमेज मिळेल ती इमेज पण काय असणार आहे फंक्शनच असणार आहे आणि ती जी काही कंपोनेंट फंक्शन आहे ती म्हणजे कशी असणार आहे स्केलर व्हॅल्यूड फंक्शन असणार विच आर डिफाइंड फ्रॉम Rn टू R. ओके So these functions are called as scalar valued function. So remember, f is a function defined from Rn to Rn is called as a vector field. Okay. Next one, limit of a vector valued function. Okay. Now what is limit of vector valued function? Same like scalar valued function. Okay. Only minor change in the definition. Look at that. Let S be a non-empty subset of Rn and f is a function defined from S to Rn. Be a vector field. Let A belongs to S and L belongs to Rn. A belongs to S and L belongs to Rn is said to be limit of function f at x is equal to a if definition is the same. For epsilon greater than 0, there exists delta greater than 0 such that norm of x minus a is less than delta implies modulus of f of x minus l is less than epsilon. This is very important. Modulus of f of x minus l is norm of f of x minus l is less than epsilon. This is only change the definition of limit of scalar valued function and vector valued function. Scalar valued function मध्ये आपण काय करत होतो तर for epsilon greater than 0 there exists delta greater than 0 such that norm of x minus a is less than delta implies modulus of f of x minus a. मॉड्युलस का घेतो तिथे कारण ते फंक्शन आर इन टू आर होतं रिअल व्हॅल्यूड फंक्शन होतं पण आता म्हटलं आर इन टू आर एम आहे म्हणजेच इकडे पण ती वेक्टर व्हॅल्यूड फंक्शन असल्यामुळे आपण इथे काय करतो मात्र इथे पण मॉड्युलसच्या ऐवजी फक्त नॉर्म वापरतो. दिस इज ओनली डिफरन्स बिटवीन the definition of limit in scalar valued function and vector valued function. Okay, limit extends to a f of x is equal to L. Okay, next concept is so now we calculate limit of the function. Okay, in vector valued function. Okay, so let f is a function from R2 to R3 given by f of xy is equal to x square y square xy. Look at this x square, y square and xy. These are all functions. These are component function. We treat it as f1, f2, f3 as component function. Okay. So find limit xy tends to 0, 0, f of xy. We have to find limit of that function. Okay. So by using definition, so for epsilon greater than 0, there exists delta greater than 0 such that norm of xy minus 0, 0 is less than delta. Norm of xy minus 0, 0 is less than delta means square root of x square plus y square is less than delta. So we consider norm of f of xy minus 0, 0. Remember we are in vector valued function. So here consider norm. Norm of f of xy minus f of 0. F of 0, 0, 0 is equal to that function x square, y square, xy minus 0, 0. So by definition of norm, this is x square minus 0 square, y square minus 0 square plus xy minus 0 square. So that becomes x raised to 4 plus y raised to 4 and x square, y square. Okay. So this is x raised to 4 plus y raised to 4 plus x square y square, which is this term is less than or equal to, here we are adding 2 for adjustment. So by adjusting 2 here we get this is the square of x square plus y square bracket square. Okay, this term is less than or equal to, since we adding here 2, so this term is less than this term. So we get here in bracket square of this term x square plus y square square, and square root will cancel. We get only remains x square plus y square, and x square plus y square is less x square plus y square. Square root of x square plus y square is less than delta, means x square plus y square is less than delta square. So we here choose delta is equal to root epsilon. We get modulus of f of, norm of f of xy minus 0, 0, 0 is less than epsilon. Therefore limit of that function is equal to 0. ओके, सेम एक्झाम्पल जसं आपण स्केलर व्हॅल्यू मध्ये फंक्शन लिमिट सॉल्व्ह केलं तसंच सेम आपण आता इथे वेक्टर व्हॅल्यू मधलं फंक्शन पण कॅल्क्युलेट केलेलं आहे. ओके.